Imagine three astronauts strapped into their capsule, ready for a full dress rehearsal for a trip to space. But they're on the launch pad. The rocket isn't even fueled. It should be one of the safest parts of the mission. And yet, it ends in a tragedy that changes everything. Today, we're talking about Apollo 1, the fire that nearly ended the moon race, but instead ended up saving it.
And that's the absolute heart of it, isn't it? This single, haunting fact. How could three of the best astronauts in the world die on the ground in a test? To figure that out, we have to understand the incredible pressure cooker that was the 1960s space race.
So let's set the scene. It's January 27th, 1967. To the outside world, it's just another step on the road to the moon, a routine test. But inside NASA, the pressure to meet the deadline, to beat the Soviets, was just immense. You got to remember the context here. This is the absolute peak of the Cold War. The Soviet Union had stunned the world with Sputnik, and then they did it again by putting Yuri Gagarin into orbit. America was playing catch-up, and President Kennedy had made this audacious promise: we're putting a man on the moon by the end of the decade. The Apollo program was the only shot they had, and that clock was ticking, loud. And the crew for this mission? These guys were the absolute best of the best. You had Commander Gus Grissom, a genuine space pioneer, a veteran of 2 previous flights. You had Ed White, the guy famous for being the first American to ever walk in space. And you had Roger Chaffee, a brilliant rookie who was about to embark on his very first mission. These were America's heroes. What they were doing that day was called a plugs-outs test. Think of it like a full dress rehearsal for a Broadway show. They weren't going anywhere. The whole point was to disconnect all the external power, pull the plugs, and see if the capsule could run on its own batteries, just like it would in space. It was supposed to be the safe way to iron out any kinks. But here's the thing nobody seemed to fully grasp. The very machine designed to protect them was a death trap. And it wasn't just one thing that went wrong. It was a whole series of design flaws that lined up to create the perfect conditions for a disaster. Okay, so let's start with fatal ingredient number 1, the air they were breathing. To save weight and keep the system simple, NASA filled the capsule with 100% pure oxygen. Now, you and I are breathing air that's mostly nitrogen. In pure oxygen, things that normally wouldn't even burn can become explosive. A tiny spark can turn into an inferno. And if that wasn't bad enough, for this test on the ground, they pressurized the cabin to be higher than the air pressure outside. This made that pure oxygen environment even denser, even more volatile. It basically turned the capsule into a pressure cooker bomb, just waiting for a match. So you have this explosive atmosphere. And what's inside it? Well, a shocking amount of stuff that could burn. We're talking miles of wiring that wasn't properly protected, flammable nylon nets everywhere, plastic switches, and get this, over 34 square feet of Velcro, which is basically solid fuel in a pure oxygen environment. The whole cockpit was a tinderbox. But this is the design flaw that truly sealed their fate, the hatch. It was this clunky, complicated 3-part system. Even in a perfect situation, it took a ground crew at least 90 seconds to get it open. But the real problem? It was designed to open inward. Why does that matter? Because with higher pressure inside the capsule, that pressure would literally pin the door shut. There was no way they could open it from the inside. Which brings us to the moment itself. The day had already been a nightmare of technical glitches and communication failures. Frustration was high. Gus Grissom had even hung a lemon on the simulator. And then, in less time than it takes to tie your shoes, everything went horribly wrong. At 6:31 in the evening, a voice, we think it was Roger Chaffee's, crackled over the radio with those terrifying words. Somewhere, a spark, probably from a frayed wire under Grissom's seat, found all that oxygen and all that flammable material. The speed is just unimaginable. Within 5 seconds of that first call, the fire was so intense it was visible on the launch pad cameras. The pressure and temperature inside the capsule went through the roof. The crew was fighting for their lives, trying to get that hatch open, but it was impossible. Just 14 seconds in, the last garbled transmission cuts out. And 3 seconds after that, the capsule itself bursts open from the pressure. The entire catastrophe took only 17 seconds. Think about that terrible irony. The fire that was killing them was also creating the very pressure that was holding their only escape route shut. It slammed the door and locked it tight. The design meant to keep them safe in the vacuum of space became their tomb on the ground. In the aftermath, a horrified NASA and a heartbroken country needed to know how this could have happened. The entire Apollo program screeched to a halt. Everything stopped, and a massive investigation was launched to find the truth, no matter how ugly it was.
And the findings were absolutely damning. It wasn't one single mistake, it was a cascade of failures. The spark came from bad wiring, the fire spread like wildfire because of all the flammable materials, the crew was trapped by a horribly designed hatch, and the whole thing was made possible by the incredibly dangerous decision to use pure high-pressure oxygen on the ground. When the dust settled, the responsibility was placed on both NASA for its management and safety oversights and on the main contractor, North American Aviation, for just shoddy design and manufacturing. It was a brutal but necessary moment of truth for the entire space program. But here's the paradox of this whole story. Out of the ashes of this awful tragedy, something incredible happened. The fire forced changes that, in a very real way, made it possible to actually get to the moon safely. Just look at the difference. The spacecraft was completely redesigned from the ground up. That death trap inward opening hatch? Gone. Replaced by a single hatch that opened outward and could be popped open in seconds. All that flammable stuff inside, ripped out and replaced with self-extinguishing materials. The shoddy wiring, all of it insulated and protected. And they never, ever used pure oxygen on the launch pad again. That nearly 2-year pause, the grounding of the whole program, was absolutely crucial. It gave everyone the time they needed to not just rebuild the capsule, but to completely rethink their entire approach to safety. So when Apollo 7 finally flew, it was in a machine that was infinitely safer, stronger, and more reliable. A machine that could actually fulfill Kennedy's promise. And that's the tough, chilling reality. Can you imagine if this same fire had happened in deep space? There would have been no escape. And maybe no answers. The sacrifice of Gus Grissom, Ed White, and Roger Chaffee uncovered fatal flaws that would have almost certainly killed another crew down the line. It's a terrible thing to think about, but it's true. So when you see those iconic images of Neil Armstrong and Buzz Aldrin on the moon, remember that their footsteps were made possible by the lessons learned from this fire on the pad. The incredible triumph of Apollo 11 was built, quite literally, on the ashes of Apollo 1. And that leaves us with a really big question, one that doesn't have an easy answer. The story of Apollo 1 is a brutal reminder that pushing the boundaries, that progress itself, often comes with an incredibly high price. It makes you wonder in all of our modern pursuits, whether it's exploring space or AI or anything else, how much risk is too much? It's definitely something to think about.